Hello, everyone. Welcome. In this video, we will look at representing weighted graphs. So we know how to represent unweighted graphs. We use list to represent vertices and use list of the list to represent the adjacent edges. So first, the representing vertices is the same. And for the edges, we need to add the weight. So here we can have an edge list. So you have the vertices from 0 to 1. So the index for the vertices. And the weight is 2. And here, and from the vertex 4 to 3. And the weight is 6. And this is the symmetric. So you have also 3 to 4, and the weight is 6. And we now define a weighted edge class as a subtype of edge. So we're going to have this super and UV, and now we need to add the weight. And we also add the methods to compare the weights. Less than, or equal to, greater than, and greater than or equal to, equal, not equal. Now this is the internal representation for all the edges. We have the neighbors in a list. And for this neighbors blank 0, so we have the vertex with index 0 and 2 all other vertices. And this is their weight is 2, and this is the 8. And so this is for 4. We have 4, 3, the vertices, 4 to vertex 3, the edge is 6. And here from 3 to 4, this edge is also, the weight is also 6. That is all in this section representing weighted graphs. We will introduce how to model weighted graphs in the next video, and see you in the next video.